Hello students, welcome to my channel. Now in this video I'm going to give a few points on the chapter electrostatics. This is in addition to what you have read in your NCERT textbook. Like first is regarding charge. Now charge, the magnitude of the charge is unaffected by motion. So it is unaffected by motion. It behaves just like mass m. So mass m is unaffected by motion under normal velocities. Similarly, this charge on a body is unaffected by motion. The second feature of this charge is, now if the charge is at rest, it will give rise to electric field. If the charge it is unaccelerated, that is uniform motion, then it will give rise to both electric field as well as magnetic field. And in case the charge is accelerated, then it will emit electromagnetic radiation. That is, it will have both electric field and magnetic field. So a rest charge will give rise to electric field, unaccelerated charge will give rise to electric field and magnetic field. Now if the charge is accelerated, in addition to producing electric field and magnetic field, it will also emit electromagnetic radiation. Okay, these are the few important features of charge in addition to the properties what you have written in your NCERT textbook. Now another term associated with charge is the dielectric constant. Basically it is the ratio, as you know, that it is the ratio of force between two charges in vacuum to the force between same two charges when placed in medium. Now it is denoted by the symbol capital K. So you already know the definition of dielectric constant. Now suppose you have a dielectric medium. And you have a charge Q placed near this dielectric medium. So we know that if this is a positive charge, in the dielectric medium this side there will be negative charges induced, and on the other sides equal number of positive charges are induced. Now say this charge is Q prime. So this is the induced charge on this side. This is Q. Now this Q prime is related to Q by the relation Q prime is equal to minus Q times 1 minus 1 by K, where K is the dielectric constant. Okay. Now the value of this K for metals, it is infinity. The value of K for vacuum, it is 1. So this is the value of dielectric constant for metals and vacuum. Okay. Now the another feature or problem, sometimes some problems are asked on this concept, wherein you have a rigid support and there are two threads with a bob attached, and both the bobs are given some same charge. So because of repulsion they are at this particular position. Suppose this angle is theta, this angle is also theta. So this is the electrostatic repulsive force, this is the weight of the ball. Similarly for this is the direction of the electrostatic force, and this is the weight of the bob. Now here you can use this relation F by mg is equal to tan theta, where theta is this angle. Okay, so this is there are problems based on this concept which have been asked both in NEET as well as JEE main. Then coming to the next point, regarding potential, or to say potential difference. Now, suppose this is point A and this is point B. Then the potential difference VB minus VA, it is equal to WAB divided by Q naught. That is the work done in taking the charge from A to B. Okay, work done in taking the charge from A to B is equal to potential difference. See, this is VB minus VA. This is work done in taking the charge from A to B. So work done in taking the charge from A to B per unit charge is the potential difference between the 2 points, where this Q naught is the test charge. Q naught is the test charge. Okay, now this important feature about this work done. See, electrostatic force is a conservative force. So work done will be path independent. So work done in taking the charge from this point to this point in a straight path, or this path, or this path, or this path, or these paths, any paths, provided the initial and final position are same, the work done will be same. Okay, then this is regarding capacitor. The force of attraction between two plates, because suppose we have a parallel plate capacitor, so this plate is having positive charge, this plate is having equal amount of negative charge. So if this plate is having charge Q and this plate is having charge minus Q, then the force of attraction between the two plates, it is given by the expression F is equal to Q square by 2A epsilon naught. Okay, now this can also be written as F is equal to 1 by 2 epsilon naught E square into A, where E is the strength of the electric field between the plates. Now, if you are asked to calculate the force per unit area, now that can be written as F by A is equal to sigma square by 2 epsilon naught. So this is force per unit area in terms of surface charge density. Sigma is the surface charge density. Next is, if you have a parallel plate capacitor, and the space between the parallel plates is filled by a dielectric. Suppose the plate separation is D, this is T. T is the thickness of the dielectric. Then the capacitance is given by C is equal to A epsilon naught divided by D minus T plus T by K. So this is the expression for capacitance, parallel plate capacitor, capacitance of a parallel plate capacitor with a partially filled dielectric. Now, if the entire space is occupied by the dielectric, in that case, the thickness, this is the T is the thickness of the dielectric, so, and D is the plate separation. If the entire space is occupied by the dielectric, in that case, T will be equal to D. So instead of T, you have to write D. Now, if in case this dielectric is replaced by a conductor, then as we have already seen, for conductor, K is infinity. So if you know this expression, you can calculate the capacitance for all the other cases. Now, in case you have number of slabs, there are a number of slabs instead of one slab. Suppose there are a number of slabs, okay, of various thickness and various dielectric constant. So in that case, the capacitance will be C is equal to A epsilon naught divided by D minus T1 plus T2 plus Tn. So basically you have to add the thickness of all the dielectrics plus T1 by K1 plus T2 by K2 plus and so on Tn by Kn. So basically these two expressions are identical. So if you remember this expression, dielectric constant with single material, single dielectric slab, then if multiple slabs also the expressions is same. Means it is all the same form. Okay, and then these things are quite simple. It is there in NCERT also. Like if capacitors are in series, then the formula is what you do for parallel in resistors. That is for series, 1 by Cs is equal to 1 by C1 plus 1 by C2 plus and all. And for parallel it is Cp is equal to C1 plus C2 plus and so on. Okay, then some more features. For a point charge, suppose this is a point charge, okay, the value of electric field everywhere you can calculate. At distance r, value of electric field is E equal to 1 by 4 pi epsilon naught q by r square. But the value of electric field at the site of the charge is always 0. Okay, the value of electric field at the site is always 0. Okay, then the other thing is, like when you are applying Coulomb law, suppose you have 3 charges, Q1, Q2 and Q3. Okay, now if you are calculating the force between these two charges, so force between these two charges is independent of presence of this charge. Similarly, force between these two charges is independent of presence of this charge. So Coulomb's law, the force between two charges does not depend on presence or absence of any other charge. Okay, this is one important concept. Achha, then the other thing is, if a charge Q is brought from infinity, okay, a charge Q, this Q charge, suppose it is brought from infinity to this particular point, then work done is Q into V. Okay, now, so this is the work done on it if this charge is brought from infinity to this particular point. Now, if you have a capacitor, okay, and if you have a capacitor and it is given a potential V, so that the stored charge is Q, then the work done or the potential energy stored in the capacitor, it is half QV. Half QV. Okay. Now, there is an interesting thing in this concept. Like, suppose this is a capacitor and this is connected to a source of potential. So this is V, is the potential source. This is the capacitor or capacitance C. Okay. Now, energy stored, potential energy stored in the capacitor, it is half QV. Okay. But work done by this battery, it is QV. So this means that potential energy of the capacitor is half of work done by battery. Okay, now for this expression for potential energy of a capacitor, you also you can write this expression in other forms also, like U is equal to half CV square, that is equal to half QV, that is equal to Q square by twice C. Okay. Now this is for capacitor. One unrelated thing, but it connects this expression with the expression for spring. So I'm writing it here. Now for spring, potential energy is half kx square is equal to half fx is equal to f square by twice k. Okay, so these expressions are quite identical. Okay, now for point charge, E is inversely proportional to r square, V is inversely proportional to r. Okay, for dipole, E is inversely proportional to r cube, V inversely proportional to r square. So this exponent of power for dipole, exponent of this R is increased in case of dipole. Here it is R square, here it is R cube, here it is R, here it is R square. Okay, for infinite line charge, infinite line charge, E is inversely proportional to R, and V is proportional to log R, log to base E R. Okay, another concept is, suppose you have n charge drops and each drop is having capacitance C, okay, and it is charged to potential V. Q is the charge on each drop, okay, and sigma is the surface charge density. Potential energy is U. Okay, so you have n drops, each of capacity C, potential V, charge Q, surface density sigma, potential energy is U. Now, these n drops combine to form a single drop. Okay, so n drops to single drop. N drop to single drop. Now, total charge of the single drop will be NQ, because n drops, each drop is having charge Q. Total capacity, it will be N 1 by 3 into C. This is the total capacity. Okay. Then potential of the single drop, it will be N 2 by 3 into V. Surface charge density, new surface charge density, total, it will be N 1 by 3 into sigma. Potential energy, it will be N 2 by 3 into U. Wherever required, you please take the snapshot. Okay. Then another concept with regard to capacitor. Now suppose you have a parallel plate capacitor. Okay, this is a parallel plate capacitor and it is connected to a battery. Okay, and now a dielectric is introduced. And this battery remains connected. Okay, then V potential will remain constant because battery is there. Battery is maintaining the potential. Since potential is constant, E will also remain constant. This is after introducing the dielectric. Okay, the capacity, new capacity will be K times the initial capacity. Okay, why K times? Because see, capacity is independent of charge, it is independent of applied potential, it depends on the nature of material. So after the introduction of this dielectric, the capacity will increase K times. Okay, so since the capacity has increased K times, the potential energy will also be increased K times. So it is Ku. And similarly, the new charge, it will be K times the initial charge. And since charge has increased, similarly the surface charge density will be K times the initial surface charge density. Okay. Achha. Now, second case, suppose you have a parallel plate capacitor and it is charged by connecting it to a battery, and now the battery is disconnected and a dielectric is introduced. Okay, so now in this case, see, battery has given some charge to the capacitor. Now the battery is removed, so now this is an isolated system, and now the dielectric is introduced. When the dielectric is introduced, see, for isolated system, charge is a conserved quantity. So it means that Q will remain constant, sigma will remain constant. Okay, but capacity, it is dependent on medium. Medium has changed. So the new capacity will be K times. Okay, but here this potential will decrease K times. So V prime will be V by K. E prime is equal to E by K, and potential energy U prime is equal to U by K. Okay, so these are few of the additional, you can call them as tricks, tips, shortcuts, whatever, but these are some things, few things, important things which you must go through before you attempt your JEE main or NEET paper. So this is the first video in this series. I'll be uh, giving the next, I'll be giving the tips on current electricity. I'm starting with the second year portions because the students who are preparing their second year examination, 12th board examination, they can also have some benefit from these tips. So, but I will be giving all the tips for both first year, class 11 topics and class 12 topics. And I hope that these tips will be beneficial for your preparation and they will help you to secure good marks in your entrance examinations. Good luck.